Okay, perfect. So this video is to go through the first activity, the math activity related to significant figures, scientific notation, and dimensional analysis. I know many of you had some trouble with this one, so wanted to go ahead and have a meeting so that you guys can revise your answers and hopefully get more points. So I did extend the deadline until the end of Sunday. So you can do a few more attempts and hopefully people can get started on experiments and activities earlier in the week so that they also have more time for more attempts by doing that. All right, I am going to share my screen and just use my document camera. And you guys can, I'm not going to probably do every question, but you guys can let me know what you are struggling with, and we'll certainly do at least a couple in each one. So I think the tricky thing with this one might have been that what it says in Canvas is different than the book. So for example, in the book, it says to round to the 100th place, right? So this would be the 10th place and then the 100th place. So you would be rounding after the 6, and 499 would round down, right? So you would get 21.46. But in Canvas, it said, at least when I did it, to do it to the 1000th, right? So some of these, in fact, most of these, they wanted you to do it differently in Canvas. And I think that's one of the anti-cheating measures that the lead for this course put in. So if you're doing the 1000th, then you would round right after the 4, the 9 would round up the 4 up to a 5, and you would have gotten 21.465. So just make sure if you got any wrong there that you were actually rounding the way it said to do in Canvas when you're placing yours in there, but you can do it the way it says here on the actual paper. Any other questions on this section? Did you guys get any wrong on this section? No? Okay. So we'll just move on to another section then. And so we're going to move on to the significant figures. These are actually fairly, I think, quick to go through, so we can just do them all. So this one has 3 significant figures because the leading zeros are not significant, right? And so that's something to keep in mind. That will play an effect for C and E, right? Because trailing zeros after a decimal place are significant, but not leading zeros, right? So this would be 2 and that would be 1. For 9.70, the zeros after the decimal, right? So it's assumed that that is significant. They wrote it for a reason because they have that level of precision, right? So all 3 of these then are significant. All 5 of these would be significant. Again, zeros after a decimal place are significant. And for this one, again, that 0 is after a decimal place, so it counts, right? You don't see a decimal place here, right? So in that case, with no decimal place, we're going to assume that 0 is not significant, right? And only say there's 3 significant figures. Same thing here, there's no decimal place, right? So we assume the 0 isn't significant and there's only 1 sig fig. We assume this 0 isn't significant, right? Because there's no decimal place. And then again, all those leading zeros are not significant, but the trailing one is, right? So did anybody have any trouble with this section and want to go over that anymore? Okay, so hearing nothing, we'll just keep going. Okay, scientific notation. And I'm just going to go ahead and do it the way that it wants you to put it into Canvas, just to make it easier. Because the times 10 to the number, right, whatever that might be, just gets put in as a lowercase e. And so it's important to follow the right format here. A lot of people are making mistakes on formatting, and that's why they're getting marked off in certain sections. So as we go through these, you'll see how to use the E format, because I'm just going to go ahead and use it right as we do these problems. Okay, so any number, right, even the number 5 can be put into scientific notation. So we assume the decimal place is here, right, and which means we don't need to move it because this number is already between 1 and 10. So we can just do 5, right, e to the 0. Now notice that I didn't do any spaces, right? No capital E, nothing else besides 5, lowercase e, and 0. Also, don't put an O or like a capital O here. Sometimes I get that as well. Make sure you're actually using a 0, right? Because the computer knows the difference and you'll get marked wrong if you do that. Okay, moving on to this one, right? In order to get this number between 1 and 10, we need to move it. So the decimal place. So 1, 2, 3, 4, 5, 6, 7, right? So we have 1.10. We have to include this 0 because it's significant, right? And then e to the negative 7. No spaces. So hopefully that makes sense to you. So remember that these two zeros are not significant, right? Because there's no decimal place here. So when we do this one, we've moved we go 1, 2, 3 to the left. So this becomes 7.1, not 7.100. Because when we convert to scientific notation, we only take significant numbers with us. So 7.1 e to the 3. Now notice I didn't write e to the plus 3, right? So that's one of those little formatting things, right, that you want to pay attention to. When we move over here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, right? So this is a big number, so it's going to be 10 to the 8. Now remember, we're only going to copy out significant numbers. All of these trailing zeros are not significant, but we do count these two because they're in between two non-zero numbers. So we would write 6.006 e to the 8. Is that making sense for you guys? Would you like to go over any of the other ones that you think might be confusing, or should we move on to the next section?
Can you do J?
Absolutely. Okay, so all these trailing zeros, right, don't count because there's no decimal place there. So when we convert it, we're going to go with 1.10614, right, and no zeros at the end because those are insignificant. And then as I move my decimal place over, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so e to the 9. So thinking about it, right, we want to underline significant numbers. Only the 6 and the 7 here are significant. 102 is significant here. The 100, remember these numbers are significant because it's after a decimal place, right? So if it's to the right of a decimal place, any trailing zeros are significant, but leading zeros are not, right? And then here we would have 3 significant figures, and here only 2. So when you convert it to scientific notation, right, you're going to end up with 6.7, right, 1.02, 1.00, 1.49, and 6.3. Another error I see a lot is students not getting their number in between 1 and 10. Like, for example, they might do 67 e to the 3 or something like that, right? So 67 is not in between 1 and 10. So it needs to be 6.7, right? So that's another error. So you want to make sure that you move the decimal if necessary to get that number, right? To be a single digit, you know, one number and then the decimal immediately.
That's what I got wrong. Oh, sorry, I'm not muted.
That's okay. Any other questions on how to do this? Or we think we've got it covered here? Okay. So let's move on then, right? Because we definitely have some harder sections coming up here. Okay, so for this one, I think this one is a little confusing. Writing the number up to 5 decimal places, directions, I think definitely students can get confused here. But what I want you to do is get your calculator, right? And your calculator, I have a couple of different calculators here, but I don't have obviously every type of calculator in the whole world. But you need to know how to do this sort of scientific notation in your calculator, right? So that's going to be super important that you know how to put this in properly into your calculator. So what I want you to do is try to do all of these problems with me and make sure you're getting the same numbers I'm getting, right? If for some reason you're plugging these numbers into your calculator and you can't get the same number I'm getting, right? Then you're not using your calculator correctly. And what I would suggest you do is I can help you, or you can also just go to YouTube and look for a tutorial using your calculator. So for example, if I didn't know how to use my Casio FX115 ES Plus, right? I could put all that in and then just say scientific notation, right? So I would be able to find a video, really doesn't matter what calculator it is, on how to do scientific notation given any calculator. And so you're just using any kind of scientific calculator. It's important that it is a scientific calculator and not just a regular calculator, right? Regular calculators cannot do scientific notation, right? So for example, I also have this calculator, but this calculator cannot do scientific notation, so it's not a good calculator. So you need to get it doesn't have to be a graphing calculator, but just a scientific calculator of some sort. Okay, so as we, first of all, it does ask you to put this into Canvas, so just go ahead and copy it right into Canvas. So I think that's A1 base is to put that number in, and that's already done for you, right? And then over here, it wants us to put in B1 and B2, and except for this one, they all have 2 numbers that we're putting in. Okay, so as you're going through this, and I'll show you my calculator, right? We can do 64.0 minus 2.15. Okay, my calculator says 61.85. So you can just go ahead and write 61.85 here. And you can put that into Canvas. You don't need to have 5 places past the decimal. So you don't have to do 61.85000. However, we did input that as a correct answer. So if you did do that, that should have been marked correct. Okay, so basically it's just the raw answer, right? Up to a maximum of 5 decimal places past the decimal you can put into Canvas. And we're not doing any rounding yet, right? So don't round this yet or do anything to it, right? This is just the first answer that you put in to Canvas. Okay, now we're going to look at the significant figures and round, okay? So because I'm doing subtraction, I want to look at how many places past the decimal. Right, so this is 1 place past, 2 places past. So my answer can only have 1 place past the decimal. So I usually make a little caret here that shows me like anything past that is not significant, right? Because I can only have 1 place past the decimal. So I'm going to take this 5 and round it up, right? Round the 8 up to a 9. So I'm going to put 61.9. Now, for any of these, you can also put the answer into Canvas in scientific notation. So you can go ahead and put in 61.9. That will be a correct answer. Okay, you can also put it in as 6.19 e to the 1. Right? That would be how you would convert that to scientific notation. So both of these are inputted into Canvas as correct answers. So, you know, at any point you can use scientific notation or not. The only exception would be like the section that said, convert this to scientific notation. Then, of course, the answer has to be in scientific notation. This one says where appropriate. So basically you can choose to use it or not. And they're both put in as correct answers. Okay, right. So I think the idea, same thing, right, with this one. This one has 3 numbers past the decimal. This one has 1, right? So our answer will only have 1 number past the decimal. But for the first part, we're just going to 6.944 plus 4.3, right? My calculator is telling me 11.244. So I would just put that into Canvas as my raw answer, right? As I think it would be called C1, right? And then now I know I can only do 1 place past the decimal. So anything past the 2 is not significant. I have a 4, so I don't need 2. So the 2 stays as a 2, right? It rounds down. So I could put in the number 11.2, right? Or I could convert it to scientific notation and put 1.12 e to the 1. Okay. Here we have no places past the decimal, right? So we want to be careful to round our answer to that point, right? Of not having any numbers past the decimal. So 114.45 minus 20, 94.45, but nothing right past here is significant. Okay, because again, we're doing subtraction, so it's looking at places past the decimal. And this one has 0, that's the minimum. So only the 94 is significant. So you either write 94, right, or 9.4 e to the 1. Okay, so we'll just skip past this last one. I think you get the idea. And then we'll move to division and multiplication. So the rules for significant figures with division and multiplication are different, right? So if I take 0.24 divided by 68, you could do 0.00, but it won't make a difference. So this is the number. Now, this calculator is programmed to give me the answer in scientific notation. If I wanted to convert it out of scientific notation, I can do that. Right, so -3 means it's going to be a really small number. So I'm going to go to the left, 1, 2, 3. Right, so it would really, some people's calculator will give them 0.003. Right, so this would have been 1, 2, 3. That's the -3. And then I can write as many of these numbers as I want, up to a maximum of 5 numbers past the decimal. Right, so I already have 3 numbers past the decimal. So I'm going to write just the next number would be 5 and then 2, but I would round it up because there's a 9. So 5, 3, right? There are other numbers that are, you know, programmed in as correct as well. But this would be one way you could answer it. right? So up to 5 numbers past the decimal, we can put in the answer in Canvas. And then, right, we need to look for, okay, which of these numbers are significant, which ones are not significant. When we're doing division, it's based on the smallest number of significant figures. So the 0.24 only has 2 sig figs, and the 68.00 has 4. So I'm only allowed to carry 2 into the answer. So only the 3 and the 5 are significant, right? So when I put my answer in over here, I can either write 0.0035, or I can do 3.5, right? E to the -3. Okay, let's do another one. So for this one, it actually gave you the raw answer. So you just need to round it, right? So this one has 4 sig figs, and the 0.00093 only has 2, right? So we're going to stop after the 6 and 6, right? So there's a couple of different ways you could do that. You could write 660. That has 2 sig figs because the 0 is not significant unless there's a decimal place there. Or you can convert to scientific notation and call this 6.6 times 10 to the 1, 2, right? So e to the 2. Okay, now let's go ahead and try some of these, right, with the scientific notation. And I can try to do it on multiple calculators, but this is where it's really important that you double check, right, that you're getting the same thing that I'm getting, that you're using your calculator properly. Okay, so on this particular Casio model, right, how are we going to input this number? We're going to do parentheses, because there's some parentheses here. 2.3, and then it has this nice nifty times 10 to the button. I can click on the bottom here, right? And then -3, there's a negative right up here, -3, close parentheses, right? Times, not quotation marks, parentheses, 2.501, close parentheses, right? Enter. Okay, so this is what this is giving me. I can put this number into Canvas in scientific notation, that's fine, right? Or I could convert it out of scientific notation, and I could do 0.00, and then again, I can only take 3 more numbers, so 575, right? We'll take from this point, or you could just put it in exactly as you see it here, right? That's fine as well. That should be marked correct. And then in terms of significant figures, this one has 4, right? But this one only has 2, and we're multiplying, right? So it's based on the smallest number. So only the 5 and the 7 are significant, right? So this is going to round up to 5.8. So I'm just going to go ahead and put it in scientific notation and go 5.8, right? E to the -3. Okay, so what about a different calculator, right? Because not everybody has that, a Casio. A lot of people have this TI calculator. It works a little bit differently than the Casio, because you can notice that there's no times 10 to the anything button here. So for this one, right, we still have parentheses. We can do 2.3, but that now you want this EE button, so you can look for that as well, right? So click that, and then -3. Where do I have a negative button? Yes, down here, -3, close parentheses, times 2.501, right? Okay. So notice how this calculator did not give it to me in scientific notation. That's fine, right? We can input this number up to 5 places past the decimal. I would at least want, like, I would want to, do all 5 like 0.00575, just because only two numbers are significant. So we shouldn't, start rounding too early, essentially. But you could do 0.0058 and that would be marked correct if you rounded, early. So we have lots of numbers being marked correct. Okay, so hopefully, is anybody having trouble with their calculator? Okay, because this is a really big problem where people are misusing their calculator, and that's why they're getting the wrong answer. Okay, are we good to move on to the next section? Okay, so this is more math operations. So let's see. We can, again, this is, can you use your calculator to put in these exponents properly to get the right answer? Let's go ahead and do the first one together. I can use this calculator if I want, just to mix it up for you guys, right? So this one, 2.50 times 10 to the is the E button, right? -1, and then times 0.3. Again, it doesn't really matter if you put in the extra zeros, but we can go ahead and put those in. Times 10 to the -2, right? Enter. Okay, so this is what the calculator spits out at us, right? Looking for significant figures. This one has 3, right? And then this one also has 3, right? Because the 300 is significant. So our answer should have 3. And this calculator, interestingly, isn't giving us 3, which is the reason why it's not giving us 3 is because it's zeros after this. So if you see something like that, you're going to write 7.50. So some calculators might, if there's zeros, they're left off. Okay, so we would do 7.50, right? Because we need 3 significant figures. And then we have the 1, 2, 3, 4, e to the -4. Okay. It does say to write your answers in scientific notation here. Okay. Let's do C and D. Those are tricky, right? C and D should be different. Okay. So if you're getting the same answer, then you're not doing it correctly. And probably what you're doing is it's a lack of understanding of what we should do in this case, right? Because it's based on order of operations, order of math operations, right? And when you see something over something else, our math operations tells us to essentially put parentheses around this, because we have to do everything in the numerator first, everything in the denominator, and then do the division. Right? Whereas here, this is written differently, and math operations would tell us to do this division first. So the calculator will basically do 10 to the 2 divided by 4 first, and then the multiplication, as opposed to the multiplication and then the division. And it changes the answer, which is kind of weird. Okay, so looking at how that would look in the calculator. Right, and I did a very similar problem to this in the pre-lab lecture video. It wasn't the same exact numbers, right? But it was basically the same exact problem with different numbers. So I hope everybody is watching that pre-lab lecture video because I'm giving you all the helpful hints and things that are important to complete the activity. Okay, so for this one, we can actually put in these parentheses, right? So 2.0 times 10 to the 2, close parentheses, divided by, and then 4 times 10 to the -1, close parentheses, enter. This gives me 500, right? So to put this in scientific notation, this would be 5 e to the 2, right? Or It could be 5.00, but I looked over here and saw that the 4 was only one significant figure. So I'm not going to include the zeros, right? It's just going to be the 5. Okay, so for this one, right, if they don't have a numerator and a denominator clearly written out, then we're not going to use parentheses. Right, so it's going to go 2.0 times, I can use this button for 10 to the, right? Oh wait, I was supposed to do that differently, sorry. 2.0 times 10 to the 2, right? And then divided by, and then we're going to put 4 times, and then again 10 to the -1. You can see the answer I got this time is 5, right? So it would just be 5e to the 0. So when you do E and F, you're going to do the similar idea, right? We'll use parentheses in this one and not in this one. So again, a lot of it is just being able to use your calculator properly and to get the answers here. Are there any questions on this section?
For D,
Yes.
I just want to make sure so if it's a single digit, we always do want to put e to the 0. We couldn't just put 5 since we have
You
to
could
write it
put,
down.
yeah, you can put 5. I did that because it says write your answer in scientific notation.
Understood.
Yep. So it specifically said to do it. I don't know if it specifically says to do it in Canvas or not, but you'd want to pay careful attention to that. So I think, I'm not sure if that just 5 is marked correct or incorrect in this section. It depends on what the instructions were in Canvas. But I'm pretty sure 5, for sure, 5e to the 0s would be correct.
Thank you.
No problem. Other questions? Okay. And so let's move on to the next section. Okay, so for this one, it says to use the appendix, which I understand is not very great because some of these, like fluid ounces, are not in the appendix, I believe. But the appendix is in here and it's linked in Canvas as well. Let's see. So what it's talking about is to use this Appendix A. And so there's a few that are missing, right? But if you watch my pre-lab lecture video, I put in a couple of extra to be able to do everything in that section. So that's where I'm giving you those like helpful hints. I'll show you exactly what I'm talking about here. This was my experiencing difficulty. Okay, so let's see. So in the pre-lab video, not here. And normally I would keep it on the information page and it's right here. I also put it directly on Canvas because I think people were maybe not finding it very well. Okay, but here, write it as 4.5. I just wanted to show you that once we get to that section, I did put in a couple more conversions that are not actually in the appendix. But otherwise, we do want to use the appendix as opposed to just you like searching your own, because the number of significant figures can be different if you just like search your own. So that's the idea behind it. So it's also, right there in the pre-lab lecture video. Okay, but how do we do this, right? So we want to use that appendix. And what we want to do is we're going to start with what's given to us, right? And we're going to go 1.00 pounds. Right? And then I know I'm going to want my answer in grams. So hopefully, and we'll have to check, right? There's a conversion directly from pounds to grams. If not, we might have to do multiple conversions, right? Like if it only went from pounds to kilograms, then we would have to do that and then go from kilograms to grams, but we'll see. So the idea is we want to go from pounds to grams. And so we're going to look up the appendix to see if there's a direct way to do that or if I need to do it via an indirect, right, method here. Okay, so let's see. So this is a mass, right? Grams, pounds are all masses. So we'll look under mass. And it does say there is a way to go from pounds to kilograms, but I also see pounds directly to grams. So that's going to be simpler, right? So I know 1 pound is equal to 454 grams, right? And that is the important one that I'm going to use here, right? So I make sure that the pounds, right, the units are going to cancel. So since this is in the numerator, that needs to be in the denominator. So I have the 1 pound in the denominator and then the 454 grams, right, in the numerator. That way my units cancel. And this one is considered precise, right? So it's not going to limit our answer to 1 significant figure. This one has 3 significant figures. This one has 3. So our answer can have 3, right? So of course, 1, right, times 454 is just 454. That makes that nice, right? Grams. Okay. So let's do one towards the bottom here that maybe will take more than 1 conversion, right? Let's go ahead and see which one might take more than 1 conversion. How about we let's try this one. I don't know if it takes more than 1 conversion or not, but since it's towards the bottom, it might. Okay, so we want to do 1 cup, right? So we're going to start with 1 cup. And we're trying to get to milliliters. So let's go ahead and take a look at the appendix. See if it's there. If not, it might be one of the ones that I added. Okay, so cups and milliliters, those are volume measurements, right? I do see cups to quarts, right? So let's see. I know I can get from cups, right, to quarts. Okay, and let's see do I have any quarts going to milliliters? I do, right? I see quart and milliliter, right? So I can go from cups to quarts to milliliters, right? And so I can just use these directly. So 1 cup, right? I know I'm going to go to quarts first, right? So 4 cups in 1 quart. So 4 cups, 1 quart. Right, and then I'm going to do quarts to milliliters. So here, right, so 1 quart equals 946 milliliters. Right, so my cups will cancel, my quarts will cancel, right, and then I'm going to have my answer. Again, this 1 and 4 and that 1 is all considered exact, so we're going to have our answer to 3 sig figs. So we just need 946 divided by 4. So my calculator told me 236.5, right? So 236.5 is what the calculator said, right? But I know that I'm only going to take 3 sig figs, right? So I'm going to put my little caret there and say, okay, I can't go past that. So the 5 will round the 6 up to a 7, right? So that's equal to 237 milliliters. So that's the idea, right? Sometimes we can go directly. Sometimes we might need more than 1 conversion, but use the numbers in the appendix to make sure, because if you use something else and they use a slightly different number of sig figs, like maybe your answer turned out to be 236 instead of 237. Maybe that's not programmed correct, right, in Canvas. So that's why it specifically says to use the appendix. All right, questions on this section then? Okay. So this is some more of basically what we were doing in the previous section, right? It's going, but now it's like word problems instead of being written out like this, right? So how many kilograms in 155 pounds, right? So we'll start with 155.5 pounds, right? And then look at the appendix to see, again, if there's a way to go directly from pounds, right, to kilograms. And I believe there was, I remember we saw that before. So we'll look at the appendix. And it was there somewhere. What was it? Pounds to kilograms, right? So 1 kilogram equals 2.20 pounds, right? So 1 kilogram is equal to 2.20 pounds. So that's perfect. We can get there in just one step. So just want to make sure that 2.20 pounds goes in the denominator so that the pounds will cancel. And the 1 kilogram in the numerator. This has 4 sig figs, this has 3, so our answer can only have 3. So we'll take 155.5 divided by 2.2 is, my calculator tells me it is 70.681818 repeating, right? But I can only have 3 sig figs. So 70.7, right? You could put 70.7. That would be fine to put this in the canvas, or you can always convert this to scientific notation, and you would do that by writing 7.07 e to the 1. Right? That would also be fine. So in this section, I don't think it says you have to do scientific notation, so it's optional. Both would be marked correct. Okay, so that is the idea. Let me see as I look through this, which ones might be harder to do. How are you guys doing so far? All right, so should we, any preference whether or not we do C1 or C2? Fairly similar. Maybe C2. C2 is probably a little bit harder. Okay, refer to the above question. If gasoline has a density of, refer to the above question means we actually have to do that one. Well, let's go ahead and do both of them then. Okay, so a Prius automobile requires 11.9 gallons of gasoline for a full tank. How many milliliters of gasoline is needed for a full tank in the Prius, right? So again, our goal is to go from, it's gallons in this case, right, which is a volume, and we want to get to milliliters, right? So we have to look at our appendix. I have multiple manuals here, so I'll just keep this one open. Okay, so let's see what we have. So it's a volume, right? And does it say anything about gallons? No. I'm sure I probably put what I wanted you to use in the pre-lab lecture. But let's see what I have here. Okay, so I looked it up, and 1 gallon is equal to 4 quarts, right? And from the appendix, I know a quart is equal to 946 milliliters, right? So those are the ones that I'm going to use. I'm going to go from gallons to quarts, and then from quarts to milliliters. So we're going to start off with our 11.9 gallons. Right, and then convert to quarts. So in 1 gallon, we have 4 quarts, right? And then in 1 quart, there's 946 milliliters. Okay, so we will make sure our units cancel so that we're left with our answer in milliliters at the end, right? And my calculator for this one, when I multiplied it all out, gave me 029.6 milliliters. So that's what I got from the calculator. But of course, I can't, all of these numbers are not significant, right? I can only have 3 significant figures. So I have to stop after the 0. So this one is an example where you have to use scientific notation, because the only way to do this would be to write 45,000, which would only have 2 significant figures, or like 45,000 point, which would have 5 significant figures. So sometimes you can't have the right number of significant figures without scientific notation. So you have to convert it to scientific notation, right? So this would be an example where we just have to, in order to be able to have 3 sig figs. So I'm only going to include the 4, the 5, and the 0. I know I'm going to write 4.50. It's scientific notation, and my number has to be between 1 and 10. And right, I moved my decimal 1, 2, 3, 4, right? So e to the 4. And that's what you're going to put in. You're not going to put in ml, right? Don't put in the units into Canvas. It will be marked wrong. Okay. So now it says, refer to the above question. If gasoline has a density of 0.750 grams per milliliter, what is the mass in grams of this volume of gasoline? Okay, so it doesn't want volume at the end anymore. Now it wants the mass in grams. So we have to keep going. And you could essentially take all of this and write it down here. So we're not rounding early, but you can also just copy this, right? So I would actually use all of the numbers, right? And not use the rounded number. Because again, we don't really want to round till the end, and we're going to continue on with this calculation. Right? So we're not going to stop at volume. We need to get to grams, right? So the nice thing is that to go from a volume, right, like milliliters to grams, we can use density as the conversion factor, because density is defined as a value in mass over volume, right? So the density, it tells us, is 0.750 grams per 1 milliliter. So we can use that as a conversion factor, right? We can use that density. We're going to put the grams in the numerator and the milliliters in the denominator so that they cancel, right? And then we can multiply that out. If I'm writing down everything that I got, right? Well, let's see, I can go ahead and calculate that out. Say 45029.6 times 0.75. Okay, 33,772.2 grams, right? That's what my calculator gave me. But again, I know I can only have 3 significant figures, so it's not significant after this first 7, right? So I could write 33700, right? That would be one way to have 3 significant figures. Or I could just convert it to scientific notation and write it as 3.37, right? E to the 1, 2, 3, 4, e to the 4. Okay, questions on that one? So density can be used as a conversion factor to go from a mass to a volume or vice versa.
I had a quick question.
Yeah.
So for C1, Why would it be three significant figures instead of one, since four is just one? Does that make sense?
Yeah, that makes sense. So that is a precise definition, I believe. So 4 quarts in a gallon is just it's exactly 4 quarts.
Okay.
Yeah, it's considered like exact. I know that's tricky. Whereas like and I think it's because both quarts and gallons are like in the English or the American system of measurement, right? So those are like precise like things. But when we go to from quarts to milliliters, we're going from like the American system of measurement, which is the quart, to a the measurement that everyone else uses, the international system of measurement in milliliters. So this is not going to be an exact value.
Okay, got it.
But
Thank you.
yeah, I know, and that's a tricky one.
Thank you.
No problem. Okay. So let's go ahead and let's do D. D is kind of tricky too, right? How fast is a car moving in centimeters per second if the speedometer reads 65.00 miles per hour? So this one is really all about modifying the units, right? So we are going to start with miles, right, per hour. And we need to convert to centimeters per second, which means we need to convert miles to centimeters and we need to convert hours to seconds. So we have to, our units are, there's 2 units to start with, and then there's 2 units to end with, and we have to convert them both. So I'll show you how I do this to keep it really organized, right? So we're not all over the place. So we want to start with what it gives us, right? So we're going to start with 65.00 miles. And when it says per hour, you can assume it's 1 hour, right? Per 1 hour. Okay. And now we want to convert to centimeters per second. And we can do that in any order. I can start working on converting the miles to centimeters first, or I can convert the hours to seconds first, right? It doesn't really matter. So let's say we decide to work on the miles, right, to seconds. Okay, so what do we have when we look at the appendix, right? We want to do miles to centimeters. Okay. So that is in here in the length, right? So let's see what we have here. So miles to centimeters. Well, I know I have centimeters to inches, right? I've got miles. This is the only one that has miles in it, right? And so it's going to go to kilometers, right? So we are actually going to have to go from miles to kilometers first, but from kilometers, we can get to meters, and from meters, we can get to centimeters, because those are all in the SI system of measurement. So they're all based on like tens. But the one that we want from the appendix that we need to know is this 0.621 miles in 0.621 miles in a kilometer. We're going to do that first, right? So we're going to do, I'm going to put the 0.629 miles, right? And then 1 kilometer. So I know I have, my miles are canceled out. So, okay, I have kilometers, but I need centimeters, right? So one thing I can remember, because it's hard to remember, okay, how many centimeters in a kilometer, right? But I always can know how many meters in a kilometer and then how many centimeters in a meter. So for me, it's just easier to go from kilometers to meters to centimeters. It's just because I can remember those numbers, right? So I know there are 1,000 meters, right, in a kilometer. So that's just something that I already know. And then 100 centimeters, right, in a meter. So we can do, okay, kilometers are gone, right, 100 centimeters in 1 meter. So that meters are going to cancel out. right? So now in my numerator, right? And do I have a highlighter anyway? I am in centimeters, right? So that's good. That's what I want. But I need to work still on the denominator because I need it to be in seconds, not in hours. I could just keep going with that, right? Because I know that in 1 hour, there's 60 minutes, right? And then in 1 minute, there's 60 seconds, right? So my hours are going to cancel out, my minutes are going to cancel out, and now I'm in centimeters per second. So if I multiply all that out, right, I am going to get 22,970, or sorry, 907 centimeters per second. And that has 4 significant figures, so I can just put that into Canvas. Questions on this one? So that was super tricky because you have to work on converting both the numerator and the denominator. But you can do it all as one big conversion if you're really organized with your units, right? And making sure that you end in the unit you want, right? In both the numerator and denominator.
Can you
Okay.
put that one in the calculator? Sorry.
Can I put that one in my calculator?
Yeah.
Is it not coming out right? Okay,
Or
let's.
no, I just can't figure it out.
Okay, let's try it together. Okay, so I have, let's see. You can't really do it very easily, but we're going to do 65, right? We're going to do, I can do divide. So I can kind of multiply all across and then start dividing if I want to do that, right? So I can go times 1,000, so times 1,000 times 100, right? And everything else is 1. So I'll just do enter. And now I can start dividing. So divided by 0.629 equals divided by 60 equals divided by 60, right? Somehow I got that. How did I get this wrong? Oh, I have 0.621 actually. What's correct? Is it 0.629 or 0.621 miles? I think that's what changed the answer here. Let's look at the appendix again. Okay, the appendix. Oh, 0.621. Yeah, sorry. So in the appendix, it's can you see that? It's not very, it's blurry. 0.621 miles in a kilometer. So I accidentally wrote that down wrong and I had 9. Let's try it again. Calculate that again. So 65 times 1,000 times 100 divided by 0.621 divided by 60. Shoot. And I made a mistake, so I get to start over. Equals divided by 60. Okay, so I did get 2907. Did you get that when you made the change, 0.621?
Yes, thank you.
Okay, yeah. So I just copied that down wrong. Okay. Who's looking forward to the next one? This one's kind of crazy. And this one, you know, I don't know why Dr. Garces put it in the way in Canvas, the way he did, but let's go ahead and take a look and see what I'm talking about here. Let's take a look at Canvas. So it is a little tricky because when you look on Canvas, he did like an extra step, which is sort of like an unnecessary step, but that's what he did. So, but we want to, you know, follow Canvas because we have to put in our answers in Canvas. So here's the actual activity. Let's preview it. And then come down here, or here. Okay. So this one. So notice that he basically has written out the units for you, right? So we're just going to copy this and set it up without numbers, right? So we're going to write in, and I'll show you what I'm doing in a second, but I'm copying it right now. So seconds times, I'm going to have miles per second times feet per minute, sorry, for mile, and inches feet times centimeters and inches. So I'm basically setting it up using the units he wants, because this is how I have to input it into Canvas. Right, so it doesn't help me to do it a different way if I cannot input it into Canvas that way. So then it has equal, and he has the answer as the last thing. Okay, so let me show you what I did here. So I basically just set it up exactly like that, right? So I looked and saw what he started with, right? And then every single conversion, right, that he wanted until the end where we got the answer. So that way, all I have to do is look up these conversion factors and put in the numbers. So what I said was the extra step is that up here, it tells you the diameter of a penny in centimeters. But he converts the centimeters to millimeters. So it's sort of like unnecessary. But anyway, that's what we're doing. So we are going to start off with the number of seconds and then look for all of these conversion factors. So seconds. So let's read through the question. How many pennies are needed? Each one has a 1.95 centimeter diameter to stretch from the earth to the sun. It takes 8.00 minutes and 25.0 seconds for light to travel from the sun to the earth, traveling at this speed, a certain number of miles per second, very fast. Okay, so I need to start from seconds, but I don't want to just start from 25 seconds because it takes 8 minutes and 25 seconds, right, for light. So we need to convert the 8 minutes to seconds and then add in the additional 25 seconds, right? So like as an extra little conversion, we can do 8.00 minutes, right? Plus we know that in 1 minute, there is exactly 60 seconds. So it doesn't limit, right, the significant figures. So that's going to give me 480 seconds, right? Plus my extra 25 seconds, 25.0. So I'm at 505 seconds, right? And that'll be my 3 sig figs. And both of these are given to me in 3 sig figs. So it's good that I have 3 sig figs here. Okay. So we're actually going to start off with 505 seconds. That's how long it takes for light to travel from the earth to the sun, right? And at the end, we want the number of pennies, right, that it would take, right, to go for that distance, essentially. So miles to seconds is given to us in the problem, right? This is the conversion factor. So we have 186, 282 miles, right, per second, so per 1 second. And then the rest of these, hopefully we can find in the appendix. Okay, so we want feet to miles, right? All of these are going to be in length. It appears that that is not, there is no feet here. So we'll have to look that one up, right? And we're going to be at, what did I look up? So 5280 feet is what I had looked up per 1 mile, right? And all of these are like drop down, so it gives you choices. So you just want to look for the one that's closest to that, right? We do know that there's 12 inches in a foot, right? You might have memorized this one already, depending on how many lecture problems you've done. There's 2.54 centimeters in an inch. That's usually when somebody uses a lot. And then 10 millimeters in a centimeter, right? And then up here, this was sort of the extra, right? Because it told us 1.95 centimeters, right, for a penny. So we could have just gone directly from centimeters to penny, but they did the extra little work of going to millimeters and then to the penny, which I have no idea why they did that. But anyway, if we convert this 1.95 centimeters, that's actually equal to 19.5 millimeters. So each penny is 19.5 millimeters in diameter, so in length. So that's essentially all of what we need to put in when we calculate all this out, right? You should be getting the number of pennies. So this is all going to be in the number of pennies. Remember, right, how many sig figs can we have? This has 3, this has a lot, this has at least, that's 3. This is an exact number. This is not an exact number, but there's 3. This is an exact number, and this is 3. So we should have 3, right? So make sure you are putting your answer to 3 sig figs here. And you can use scientific notation because it's going to be a really large number, obviously, from the number of pennies, right, to get from the earth to the sun. So you're going to, you should expect a really large number, a really large exponent. Okay. Questions on this? Right, so then I believe it does ask you to go like, how much money would that be? So this is the number of pennies, right? And you just need to get to the number of dollars. So everybody should know there's 100 pennies and $1, so you can figure that out. That makes sense? All right, that one was kind of a really, really difficult one, right? But remember that all of this was given to us in Canvas, right? And you should always be looking and seeing, okay, what's in Canvas before you even start the activity. Okay, so I just want to point a few things out, right? You can go ahead and, do another attempt at this because it's open until Sunday night. But like, let's look at next week, right? Well, first of all, I'll point out while I have you all as captive audience, that you need to do the safety quiz. So everybody should have picked up their chemical glassware kit and their the other materials that were provided to you by Bryce. So you need, and you can watch this safety video and read about the safety policy, and then take this safety quiz, right? So we can preview this quiz. It talks about, and I put this in an announcement, all the things that you need for the quiz, right? So it's not just the glassware kit and the chemicals from Miramar, but that is important, and I'll be looking for that. But you also need some baking soda, some oven mitts, a first aid kit, a fire extinguisher, and so on. So once you've gathered all of your supplies, including some sort of ID, picture ID, you're going to take some pictures of you, with your safety equipment on, your lab coat, your goggles, and having everything, that you need, this entire list and the kit and everything. So that's the last question, is to like upload some pictures. So make sure you've collected everything. And once you've done that and you've watched the safety video and read the safety information, you can take this safety quiz, which is due in 2 days, right? So definitely, I'll be sending out a reminder to do this, or many reminders for some people who don't do it quickly enough for my liking. Okay, so Next week, right, which is, by the way, already open. So, you know, as soon as you can start working on it, we're doing an experiment. You do need to get the pennies. So we do need at least 10 pennies that are like pre-1982. So if you don't have those at home, that's why it talks about going and getting some pennies from the bank. And you're going to be doing some measurements, right? But first I want you to start here. Watch these videos, right? These 4 videos. Those are a good introduction to the important information. And then click on the information page. I've tried to make it a little more obvious this time. This is the pre-lab video, right? So you need to watch this before trying the experiment because I'm going to give you helpful hints and things. This is the PDF or PowerPoint, depending on which format you like better. They're the same thing, just in different formats. That matches the slides that I go over in the pre-lab video, right? So you can have those with you to refer to if you would like. These are just links to the experiments in the online lab manual. Now, some people will wonder, why did I make you buy a lab manual if I'm providing you it online? And the answer is because, first of all, you'd have to print everything anyway, which would probably cost you more than just buying the lab manual. But in addition to that, you can bring your lab manual to the lab exams. We have 2 lab exams, and you can bring your lab manual with you. So it's easier if you just have all the appendices, you know, you have the entire thing printed, than trying to like print off every little thing to bring with you. So that's why. But having this linked here is nice because it's like color coded and your printed one is not color coded. So sometimes like people will look at it too, because in some of the experiments I actually are like, they're color coded. So it's helpful to be able to like see that color. And I'll try to point that out as well if something is important that you look at the online one for to see the colors or if that matters. Okay, so you need to take measurements and you need to do so to the correct level of precision. That's what I talk about in this pre-lab video. So if you're not watching that, you have no idea what level, how to measure things properly, and you're gonna get everything wrong. Okay, so definitely take actual measurements of all the pennies. Don't just add random zeros at the end, because I might say like, give me the number to the nearest hundredth, right? So don't just, you know, write 1.90 for everything. Like if there's a 0 for every single thing, I'm going to think that you didn't measure it, right? Because sometimes it might be 1.91 or, you know, like you're estimating that last number. So I can tell if people are actually taking measurements or just making up data, okay? And, you know, here's additional videos on how to take length measurements to the correct number of significant figures, how to take volume measurements to using a graduated cylinder. You'll need to do that for the experiment. So definitely go over this whole information page before you even try any part of the experiment. There are 3 parts to the experiment. There's the pre-lab, the actual experiment data sheet, and then the post-lab, right? So you'll want to complete all of those ideally in this order. Some of them may have multiple attempts and some of them may not. Like if you're just uploading something, I don't give multiple attempts for that because you don't need it, right? But if it's like a pre-lab, then I might give like multiple attempts. So always pay attention when you click on something, right, to see what does it say, right? So are multiple attempts allowed? Yes. It's going to keep the highest. How many attempts? You're going to get 2 for the pre-lab. So make sure you're always looking and seeing the way it's been set up. Okay. Questions?
I just had one about the availability of the answers for the first lab. I put it in chat.
Oh, okay. I'm not looking at chat because I'm screen sharing. So hold on, let me look at the chat. Yeah, so yes, it will be available once the due date expires. And I know it's not ideal the way it's set up with, having multiple answers in one question. It'll tell you like, oh, you got 6 out of 7, but it doesn't tell you exactly which one you got wrong. So if you're ever really confused about that, then you can always email me and I'll let you know which one you got wrong.
But when the
If
answers
it's a
are
situation
released,
like that.
but when the answers are released, it'll like show all the detail of which ones I got wrong and the correct answers on the actual quiz itself, or is that
Yes.
okay?
So it'll definitely should show that. You might want to, for the first one, just take screenshots of your answers just in case. You never know. But I believe it should still say all of your answers and then show you the correct answers.
Okay.
You should be able to compare directly, but always never trust Canvas completely. So I would always like screenshot, especially like if you're going to go from one attempt to the next attempt. Like, I don't know. I'm always worried that it's going to have erased something and then I don't know what I put before.
Okay. Thank you.
Yep. Any other questions? Can we do C2 and E? Oh, did we do those already? We did do C2. Yes, we did those. We're good on that. Okay. Well, feel free to ask me more questions now. Otherwise, I'll let you guys go. Thanks for showing up on a Saturday. I just felt like there was enough really low scores that I was a little concerned about you guys and wanting you to understand this because, significant figures, scientific notation, it's going to be important throughout the whole semester. You're welcome, and I'll see you guys later. No problem.